This is problem 7-40 from section 7.1.3 homework. It says find the x and y intercepts of the quadratic function y equals 3x squared plus 6x plus 1. So one thing we might possibly do, if I know you, is probably you'd want to factor this. So let's go ahead and try to factor it. Now I'm going to do it with the generic rectangles, okay? Which is what we spent a few days on at the beginning of this year, factoring using these. And it's especially helpful when this number is not a 1. Sometimes that gets hard to figure out the old way. So I'm going to plug in my 3x squared in the bottom left corner. And my constant term is going to go in the top right corner. So this is when we'd make our diamond and multiply those two corners of my box together to get 3x squared. In the bottom goes my 6x. Now, this is when I have to figure out the diamond problem. And I need to multiply something to get to 3x squared, and it adds to 6x. So thinking of things that multiply to 3, it was just 3 and 1. That's it. Can those add to 6? 3 plus 1? No, gives you 4. So I can't do this. So there's nothing that works for my diamond problem, which means I cannot factor this. So does that mean that there's no x-intercept? Well, no, you guys know another way how to solve for x, and that's going to be using the quadratic formula. Which the quadratic formula is x equals opposite of b, or you may call it negative b, plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Some of you also know the song, so you could sing that song if you're doing the quadratic formula. So I'm going to plug in my values for a, b, and c and try to get x. And I can also always check my answers that once we do get them on the calculator and verify. Okay, so negative b, so that means the opposite of this term right here. So negative 6 plus or minus the square root of b squared, which was 6 squared, minus 4 times a. A is the number in front of x squared, and that was a 3, times c, which is the constant term, which is a positive 1. All divided by 2 times a, which was 3. Alright, so now we're going to calculate this answer. So I have x equals, so I'm finding my x-intercepts, negative 6 plus or minus, let's figure out what is under the square root sign. 6 squared gives me 36, minus 3 times 4 times 1 gives me a 12 under here. 2 times 3 will be a 6. Okay. So I'm going to simplify this some more. Negative 6 plus or minus square root of 36 minus 12 is going to give me 24 divided by 6. Now, I don't know the square root of 24. The square root of 25 would be 5, so I know it's kind of close to that. But the book is leaving your answer in with a radical in your answer and plus or minus. Now, if we had to graph this, it would be more helpful to change it into a decimal so you actually know what that is. So I'm going to, since they are leaving it in radical form, I'm going to rewrite this 24 as 4 times 6, right? That's equivalent to 24. So I want to simplify that radical. So I'm going to think, okay, what is the square root of 4? Well, that's 2. Square root of 4 gives me a 2. So maybe let's back up a second. So I'm going to break this up into 2 square roots. Okay, so I'm breaking up that square root of 4 times 6 into 2 of them. Now, if I ask you what's the square root of 4, you can tell me. That is a positive 2. Times the square root of 6, I'm going to leave it as the square root of 6. So I don't know what that is. Again, if we had to graph this, it would most likely help you to change it into decimals, but since you don't have to, you're just finding it, this is going to be the most accurate measurement. If you had decimals, you would have had to round. Okay, so this is almost there, because we can simplify this a little bit more. So if I look at these numbers in front here, they're all even numbers, right? 6, -6, 2, and +6. I can divide all of those by 2 and have a simpler answer. Okay, so if I divide -6 by 2, I'll be left with -3, plus or minus 2 divided by 2 is 1. So I have 1 times the square root of 6, or just the square root of 6. 6 divided by 2 will leave me with the 3. So this will be your final answer in the book. Okay, so remember I have plus or minus, so if I did have to graph this, I should have had 2 x-intercepts because of the plus and minus. Okay, so that's finding the x-intercepts. It also asks way back up here to find the y-intercepts. Okay, now we attempted to factor to find the x-intercepts. So we were going to, if we could have factored, we were going to set y equal to 0. And in this one, we're going to set x equal to 0. Now you're going to set the opposite value equal to 0. So I'm finding the y-intercept. I'm going to set x equal to 0. So, in our equation, which was this, y equals 3x squared plus 6x plus 1, I'm going to plug in x equals 0. So 3 times 0 squared plus 6 times 0 plus 1. Now this equation was written in standard form. The next problem in the homework, if you've gotten to that one, they want you to change it from standard to graphing. So anytime it's in standard form, which is when it's ax squared plus bx plus c, your y-intercept is always going to be just this last term, because everything else drops out to be 0. So my y-intercept is really 0, 1, if I write it as a point. Ooh, that's a bad looking point. Let's make it nice and pretty as our final answer. So 0, 1, because x we plugged in for 0. So here's our y-intercept. We found our x-intercept above, which had the radical still in it. This was our x-intercept.